So lesson 28, we're going to take a focus on square roots as per the title of this section, lesson 28. Really the goal here is to solve for x, just as any other multi-step, two-step equation that's out there. The only thing you have to be careful of in all reality is when we look at these, you've got either this symbol right here, which is a square root, or you have this symbol right here, which is a cube root. And so other than that, you just have to be mindful that the same idea happens, that if we were to have a minus 6 right here, and we were to add 6 on both sides, we'd get this 10. And then we would square root this x by undoing it. And so undoing a square root is to take a squared on both sides. That allows these to cancel, and that's going to yield this 100. So by same comparison, we have this same minus 6 over here on the right. And so if this is a minus 6, we would add 6 to the other side. We get this exact same 10 that we had before. But this time the difference is it's a cube root. So to undo a cube root, you have to put a cube on both sides. So in this case, your result is 1,000. Now you do have to check your results each time because you have to make sure you actually get the result. If you don't get the result, then obviously we'll get something called an extraneous solution. And we talked about that Friday when I came by and visited the class. If the solution doesn't work, then it fails. So for example, if I put this 100 in here, and I said the square root of 100, and I minus 6, I want to see if it actually equals 4. And in this case, it does, so this answer checks out. This one also checks out if you were to test it out. In comparison, if you looked at numbers 3 and 4, if I was to minus 6 on both sides, we'd get the square root of x equals negative 2. And if we squared both sides by doing this and this, we'd get x equals 4. But then if you went back in and checked this one, the square root of 4 and then plus 6, that would be 2 plus 6, and that's equal to 8. Well, that doesn't actually equal to 4. So this 8 is called an extraneous solution, and it does not work. So that's really pretty much the goal of this lesson. So if we looked at example number 1, the focus would be to isolate the variable. In other words, we want to get everything alone. And in this case, when we isolate the variable, the first thing we do is we have to isolate the square root if we're going to make this work. So I see that my radical is here. The only thing that's not currently underneath that radical is the 2. So we're going to add 2 to both sides. And then when we do that, we're going to get the square root of 3x plus 5. We add 2 to this side, and we're going to get a 1. Now that we have that 1, and we have the square root isolated, we can now square both sides. That allows that square root to cancel. And so now we have 3x plus 5. 1 squared is 1. And then now we just have a two-step equation. So we would minus 5 to this side. So 3x would equal negative 4. And if we divide by 3 on both sides, we get negative 4/3 for our result. And again, with any of these that you want to check, you want to make sure that it works. And so you would just come over here to the side, and you would say the square root of 3 times negative 4/3 plus 5, and yet minus 2 behind the radical. You want to see if it does actually equal negative 1. So 3 times negative 4/3, you would get negative 4, and then you'd have plus 5, with a minus 2. Again, we're trying to see if it equals negative 1. So this becomes the square root of 1 minus 2 equals negative 1. And this does, in fact, equal negative 1. So since that is true, then negative 4/3 is, in fact, our answer in the given case. So that's pretty much the example or the idea that we're playing with in all of these. What follows next in the section is several exercises. You've got 5 through 12 to try and practice and see how those work out. I'll model 2 more, maybe 3 or 4 more, we'll see, and see how that plays out. But again, you can see in this one that everything here is underneath the square root. Since that's the case, we can go ahead and square both sides because the radical is already isolated. So now that simply leads me to 2x minus 3 equals 121. I can add 3 to this side, so 2x is equal to 124, and then when we divide that by 2, we're going to get an x value of 62. Same thing right here, but notice there's a cube root. So to undo a cube root, we have to take the cube of both sides. Never hurts to put this in parentheses, so that way when you cube it correctly. So again, these would cancel, and now you'd have x minus 6, and then negative 3 times negative 3 is 9, and you multiply it by another negative 3, you're going to get negative 27. So now we would minus 6 over to this side. So negative x is going to equal to negative 33. We're going to divide by negative 1 on both sides, and x will equal 33. Again, note in these two, in this case, there is nothing behind the radical. The radical is already isolated. That has to be the first thing that needs to happen. If there is anything behind the radical on the same side, you need to either add or subtract or multiply or divide to get rid of it first before you do anything else. So if we looked at our next example, you can see in this case, the radical is not isolated. So the first thing I would need to do is add 9 to this side right here to see that now the radical is isolated, and then the right hand side is equal to negative 3. Once that radical is isolated, then I can cancel the radical with a square on both sides that allows that to cancel. So now I have x plus 5, and that's going to be equal to 9. And then when we subtract 5 on both sides, x is going to equal 4 on this side. Now again, make sure we're checking our solutions. I did not check the last two, but for example, if I was to go back and check this one, this would be 4 plus 5, so we'll make a little note that we're checking. And then I got a minus 9. We're trying to see, does that actually equal negative 12? Well, 4 plus 5 is 9, so the square root of 9 is 3. So 3 minus 9 is going to be negative 6. That does not equal negative 12. So this one is actually no solution, only because it didn't work out. Now the next one is kind of nice and interesting as well. We have a radical on both the left and the right. They are both isolated. So since that's the case, I can square this side, I can square this side, and these are kind of the easiest ones to manipulate because now basically the radicals don't mean anything in this particular type of problem. And so that just becomes a basic multi-step equation. I won't work this one out, but if you were to work it out, you would get an answer of 16. If we looked at number 9, same idea. Notice the radical is not isolated. So the first thing that I would have to do is I would have to divide both sides by a negative 12. Because right now that negative 12 is multiplied to the radical, that would allow these to cancel. And then you would have the square root of x minus 6 is going to equal to 18 over negative 12. And then again, you can continue to solve and things like that from there. A 6 does go into both of these, so you could actually simplify that before doing any other work. And so 6 goes into both, so 6 goes into 18 3 times, and 6 goes into 12 2 times. The only reason why that's beneficial because now in the next step, when you square both sides, it actually makes this a little bit easier to square. So you get x minus 6 on the left, 3 squared is 9, and negative 2 squared is 4. And then you could add 6 to the other side. But anyway, again, when you solve this one, you're going to end up being a no solution, because when you do add this over and you put it back in, you're not going to get 18, so that's not going to work. Likewise with number 10, same thing. We've got this 3 right here, so we're going to want to divide both sides by 3 first, because remember the first goal is to isolate the radical. Once you've done that, those cancel, so you get the cube root of x plus 2. 12 divided by 3 is 4. And so then, again, you have to cube both sides. So to get rid of a cube root, we cube. And then so those cancel. And then so you're doing 4 to the third power, which is 64. So you get 64 right here. And then we minus 2 to the other side. And x is equal to 62. This continues. You're welcome to try number 11. You're welcome to try number 12. These kind of do the same thing, except notice you have a square root with a radical. These will not cancel each other because of this minus sign. So if I did that, again, notice the radical is already isolated. So we square both sides. So those cancel. So now we have x squared minus 5 equals 4. Because this is a radical piece, you can do this in one of several different ways. But in this case, I'm going to go ahead and add this 5 to the right. And so now we get x squared equals 9. And to get rid of x squared, we square root both sides. So we actually use a square root here. And so we square root both sides. And now x is going to equal plus or minus 3. Same idea here. You can see that this is already isolated. So we are going to square both sides. So now we get x squared plus 8x. That's going to equal 9. In this case, we will end up needing to move this over to the left. So we get x squared plus 8x minus 9 equals 0. And so this one is actually factorable. So we could write x plus 9, x minus 1. And so then x is equal to negative 9, and x is equal to 1. Again, always you want to make sure you consider to check your answers before you do that. I'm not doing that because I'm just modeling the process of solving these radicals. In exercises 13, 14, and 15, this is traditional multiplying. This here is called a conjugate. It's a conjugate because you got a square root of x plus a 2 and a square root of an x minus 2. Notice the plus 2 and the minus 2 are not under the radicals. So in that case, when we multiply radical to radical, you're going to end up with an x. And then this one times this one is negative 2 square root of x. The inside is plus 2 square roots of x. And then the last ones are negative 4. Now, because they are conjugate pairs, these two cancel out, and so you end up, with x minus 4 as our answer. These are not conjugate pairs. They look like they could be, but again, the difference is they are the same sign, where these two are opposite signs. And so if I multiply these together, again, you would end up with x, and then plus 4 square root of x, then another 4 square root of x, and then a 16. So these in the middle will combine, and so you get 8 square roots of x, and then plus 16. So that's kind of how these play out in that design. You can try number 15 on your own. So if you want, you can pause the video, give it a try, play around with it. But in the end, you should get the answer of x minus 5 if you decide to do that. The only other kind of things that are in this section is they're going to give you some fractions where they're going to want you to multiply each one together. One is a conjugate pair, one is just a radical. And so if we were to multiply this one, it would look like this, where you multiply by the square root of x minus 9 on the top and on the bottom. And so if you do that, when you multiply this one and this one, the square roots cancel. And so you get in the denominator x minus 9. And then in the numerator, you get x minus 9 with a square root of x minus 9. These actually end up canceling. And so then your final answer is the square root of x minus 9. The other one, by contrast, is a little bit different. Because they are not all underneath the radical, I have to actually multiply this one by the square root of x and a minus 3, the conjugate pair again. And of course, whatever you do to the bottom, you have to do to the top. And so this one becomes a little bit more interesting of work when we multiply these together. Because these are conjugate pairs, you still end up with x minus 9 in the denominator, but then the numerator, whenever we solve these two together and multiply these out, it becomes a little bit more interesting, where you have, but again, if you look and be real careful, this x minus 9 is already there, and you get this square root of x minus a 3, these cancel, and you get the square root of x minus 3 as your solution in that design. The only other things in this section are a couple of exercises like this one, where they ask you to do the same thing that I just showed on the other slide. You're welcome to do that one if you want to. They have this one here where it says solve the radical. Again, you're welcome to try these if you want to. That's really up to you. I'm not going to model these. These are really an option for you to practice if you want to. Once you've done that and gone through this video, then you're going to look at the problem set at the end of this section. So we'll say this is lesson 28, problem set, and we're going to recommend that you practice numbers 6 through 21. So number 6 through 21. This would count as a homework assignment. And of course, if you have any questions, just ask. But you should be able to go through these and answer these. And of course, if you get stuck, go back and rewatch parts of this video. Take some of the notes down into your notebook if you need to. And in worst case scenario, come see me and I will give you some first-hand help. Thank you.